Continue doing this screencast. So if we look at the question, it actually talks about what we need to do. We obviously need to complete the DAC class, right? What do we need to write in order to complete this? Usually, yes, constructor. So when we are doing AP type questions, like we need to see, usually when it asks you to complete a class, you usually need to write the constructor. And what are the most important things you need to know when you're creating a constructor? The variables, the arguments. Like, what do we need in order to construct something? When you go to McDonald's, what does the waiter, like, how do you call that person? Like cashier need to know in order to place your, like, give you the food that you want. Like maybe the number of the meal if you're ordering some sort of like valued meal, or the actual name of the food item that you need to order. So that could be multiple constructors. So that constructor, as we can see here, we need to know the ranks, the suits, and does it come with the value? Yeah, so points values. And we're creating a DAC of card, not just one. So it's going to be an array of values, right? So that's the idea of a DAC constructor. Then we need to create a method which is empty, return true when the size of the DAC is 0. So that's exactly why we need an array list instead of an array, because an array, will the size of an array change? No, it does not. So and then the size of it, the current size of the number of cards in the DAC. This method deals a card by removing a card. So take something from the array list and return it, remove it from the array list. As simple as that. Yes? But there are two algorithms. When you're reading this kind of question, you can go very deep in the beginning, or you can skim through it. Okay? So just look at how long a paragraph is so that you can understand that, and then just go on and start coding. Once you have completed the DAC class, find DAC tester.java file in the activity2 starter code, which is already there, and we know by the naming convention. The tester class usually just call the class that we've created and see if it actually works, right? So we have a pretty good overall understanding of this, right? So we've already explained the relationship between a DAC and a card before we even begin, right? Doing this activity. So now let's complete the DAC class and then finish the questions. Answer the questions. Huh?
Why do they only use a regular array?
You mean for this?
Yeah.
Because when we're creating a DAC, we know exactly what we want to put in for the DAC when we construct it.
But
right?
The DAC itself is made up in array list, and each card is an argument.
So to rephrase the question, it's like when we're creating the DAC of card, why are the arguments an array instead of an array list? Is that true? Is that what you're asking?
Yeah.
Okay. So the advantage of having an array list is that if something is dynamic, we can kind of change its size, right? When we are doing a constructor, we actually need to know all the values, right?
Yeah.
So is it going to change?
No.
So for the constructor, you don't really need an array list. Array list is actually slower than array, because what is an array list? An array list is an array that implements the list interface. So that's an extra layer of it. So it's a good balance, and it takes more space usually when you expand that. So when you create an array and you put the values there, it's just a fixed size. Okay? So let's complete is an excellent question, by the way. So now we have the DAC class here on the screen, and obviously we do need to create complete the constructor, right? So first of all, when we call this constructor, do we know the size of, like, how many cards are there when we receive these three arguments? Can we find out the size, like how many cards we're creating by just
like how many ranks there are.
How many ranks there? Because the ranks, the suits, and the values, they should match, right?
Yeah. But in the one in the activity, it only had 2 like suits.
Okay, let me get back to the activities.
Like it only had blue and red.
Mm-hmm. So,
Yeah.
how many cards does the deck contain in this case?
It should contain 3, but it only has 2 suits. So how do you know like which
That was
suits?
an
match?
example as well. So you pair up all those ranks with each of
Yeah.
the suits.
So there's a blue jack, a
So
blue
you-
queen, a blue king, and then a red jack, a red queen, and a red king.
So what are the total numbers of card that we are creating in this example?
So it's the size of the ranks times the size of the suits.
Yes, so in this case, in question 2, that would be 6 cards. And there are 3 different points values, right? So we can actually derive the size of like how many cards we are creating by multiplying ranks and suits, right? So in this case, the first thing, like there are only 2 field variables in this class, the deck class. Which one can we already like kind of define the value? Size. Size equals to deck.
Equals to ranks
Ranks
dot size.
multiplied.
Wait, why ranks? Don't you have to have like it's an array, so don't you need to get the length of the ranks?
Yes. Is it size?
It's length
Why is it not size?
because it's not an array list.
Very good. Is it parentheses?
No,
Because it's a
array.
property of the array. Okay, so size we need the parentheses, and also for string is a method. Okay, for an array it's just dot length times multiplies.
Suits dot.
Awesome. Okay, and if you want to make it clearer, you can always do this dot size, but I'm going to skip that because you can do this, right? This dot size. Then we are actually referring to this very explicitly. Okay.
What's the this like?
Is a self-referencing term because you can do super dot, right?
Oh,
So
yeah.
kind of distinguishing that. So now we can know the size by multiplying the rank and the suits. If you are going to put a comment, what will be what will that comment be?
The number of cards.
Number of cards.
So why did you put this?
Hmm?
Why did you put this?
It's just to make it clear. You don't have to do that. Yeah, it's kind of redundant here. It's just to make it like clearer that you're referring to this class, not the superclass. Mm-hmm.
And the memory card.
Okay, so how can we create all these 6 cards? For loop, not just one.
Multiple.
A nested for loop, right? So 2. So we can begin with ranks or begin with suits. How does it relate to the values? So if we look at the question, we know that the values are correspond to the ranks of the card, right? Is that true? So maybe, like of course we can begin the loop with ranks and then suits inside as the inner loop, but I'm going to do it the other way around.
Wait, do suits.
I equals to 0, I smaller than suits, dot length, I plus plus, oh, parentheses. Does it make sense to you?
Yeah.
So we're going over, first of all, how many suits. So if we look at question 2, that will be blue or red, right? So we do blue first or red first. So in this case, we're going to do blue first. And then we're going to go over blue jack, blue queen, blue king. Why are we doing that? Because when we're going over jack, queen, and king, the corresponding points value will be 11, 12, and 13. Then if it is the inner loop, it will make the counting easier. Right? If we do it the other way around, we do jack, blue, queen, blue, king, blue, then the counting will be a bit different. It's not undoable, it's still doable. Okay, so how can we create a card and put it in the cards list? Do we need to initialize the array list?
Yeah.
Where should we do that?
Above.
Yes. Cards equals to
Wait, what?
Array list. New array list.
new array list. Why not list?
The dynamics.
Well, think about the topic we just went over before the break. What is a list? A list is an interface, and we're creating an instance. We need to use a class that implements the interface, which is array list. Right? So array list, and then card, and then just parentheses, right?
Mhm.
Initializing the deck. The array list of cards. Array list of cards. Alright, so now, in order to add an element in an array, yes.
Why don't you just initialize it at the beginning, at the top?
Here?
Yeah, or at the or you have,
Because it's private.
Ah, it's okay. Yeah, you can do that, but
so you can set it equal to array list.
yes. I think you can do that. Let's see if it is going to complain. No, it's not. Oh,
Or you need to have the
oh yeah,
parentheses.
parentheses. Yeah, you can do that, but it's just I try not to modify it here. All right, so and we usually declare it when we need it. So for some few variables like this one, maybe you can probably do it before you even call the constructor. Anyway, in this case, we have a nested loop, and then we are going to add a new card, right? New card, which is going to be, what do we need to put in to create a card? So let's have a look at the card constructor. All right, rank, suits, and points value, right? Where do we get the rank? So it will be ranks, and then what is the value that I should put here?
I. Or J.
J, because we're going over ranks with J value, and then the card suit will be suit I, and then
Point value.
points value is just J. Oh, I just realized actually it doesn't matter the way you nested the loop, as long as you use the same counter for ranks and points value. It should be good, right? And I'm missing a parenthesis, I think. Yep, values. Oh, values. It's not points value, it's values.
Activity 5 this is weird.
Alright, so when I compile, there's an error in its empty method. Why is that? Yeah, because we are supposed to return something, but we did not return anything. What it means is there's no syntax error in this method. Okay, we need to return Boolean, right?
Yeah.
So, when do we return true and when do we return false?
When the size is 0.
When the size is 0, if, well, it could go to negative, right? If there's some error.
It's not equal to if statement because it's not.
Hmm?
We have to return something.
Yeah. Okay. Do we need to return something? Yes. Because Why is that?
Because there's a Boolean return.
Boolean. So we need to return a Boolean because it's a contract that we kind of declared in the beginning. Alright, so this one should be quite straightforward. I'm not going to explain too much. We're just checking the size of it. If size smaller than or equals to 0, return true, and then just return false. You may ask, why don't I need curly braces? Why is that? That's only one line, okay? When we compile it, it's probably going to complain about the size. And this is the accessor method. So in theory, if we want to do it properly, it shouldn't be size, it should be get size. But anyway, it's named like this, so we are going to return size. Or if you want to make it explicit, you can do this size. It doesn't matter, but then it's your, we can always do this dot size. Alright, so shuffle. Randomly permute the given collection of cards and reset the size to represent the entire deck. I think this is like to be implemented in activity 4. So I'm not going to go over that. But then the deal method, we have to complete it here, yes? What should we do?
You can use an if statement for the null.
Yeah. Well, like, because you're using the second algorithm, right, for deal? Because you're just using size.
Well, so what Mia just did is not about what she said, it's about what she's referring to. She's referring back to the document. From time to time, even when you're in the AP exam, you don't just focus on the code that you're reading. When you're trying to write that method and you're not sure about what you, even if you're sure, check that again, all right? If we look at the documents deal, there are 2 algorithms. Algorithm 1 is, because the cards are being held in an array list, it will be easy to simply call the list method that removes an object at a specific index and return that object. Removing the object from the end of the list would be more efficient than removing it from the beginning of the list. Why is that? Why is that?
From the end of it, because it's just size minus.
Yes. So remember, array list is still just an array implementing the list array. Alright? So you actually need to shift it if you remove the first one. But if you just remove the last one, it would just change the size of the entire array by copying the rest of the array without changing the index. So it's more efficient. Note that the use of this algorithm also requires a separate discard list to keep track of the dealt cards. This is necessary so that the dealt card can be reshuffled and dealt again. Alright. What is the second algorithm? It will be more efficient to leave the cards in the list. Instead of removing the card, simply decrements the size instance variable and then return the card at size. What is it talking about?
You just take the card that you want to remove, stick it at the back, return it, and then like the size of the array list shrinks by 1, so it's gone.
Well, like for the second one, it's not really like you're not taking away anything. Like you're just like you're not even like you're just taking the like the value of size and -1, and if that's 0.
So the first algorithm is this. I have an array list, and then I do it, right? But I actually need to keep track of it. The second method is I have the deck of cards. When I deal one, I kind of do. I dealt one card. I'll mask it. It's still in the deck, but you wouldn't see it. The next time I start dealing, I'll start here. I'm not changing because I'm just changing the size, accessible by other methods. So, other methods, when other methods are trying to check the size of it, I'm just going to tell them now. It's like if originally I have 10, I have 9, but I actually have 10. I'm not showing you that I have 10. So it's not reachable by other methods.
Would it be harder to shuffle if you did it the same way?
What would that be a problem with the shuffle?
Yeah.
Depends on how you write the shuffle code, right? If you save it here, then you need to actually do some checking algorithm in a shuffle So it depends on how you implement it. So do you want to try implementing one of the algorithms yourself? All right. I'm going to pause the video a bit, and in 2 minutes time, I'm going to come back and finish this do method.